Hello class. So this is the first video lecture for environmental chemistry. We're in chapter 6. I'm going to do partially a review here because some of the things we covered, that was quite a while ago. So the first part's going to be a review, right? So when we left, we had talked about the concept of a mole. We had 1 mole of things equals 6.022 times 10 to the 23 of those things. It was similar to a dozen, right? You have 1 dozen things equals 12 things. The concept was similar, right? And that's why I talked about dozen first. Let's quick go over an example though to review this, okay? So, example. How many gold atoms are in, let's see here, 1.5 moles of gold, all right? So pretty straightforward, right? What are we asking for? I'll write it out like I always do. We're asking for a number of gold atoms. Question mark. We're given 1.5 moles of gold. In this case, we're simply going to go from moles of gold to number of gold atoms. All right? So it looks something like this. Starting off 1.5 moles of gold. Right? This is our ratio, right? 1 mole of gold equals 6.022 times 10 to the 23 gold atoms. Well, I want moles to cancel, so I put that into the denominator. This is Avogadro's number, I put that into the numerator. I didn't leave myself enough room as usual. That's it, right? Moles, numerator, denominator cancels. Left with number of gold atoms, grab your calculator. And I'm getting 9.033 times 10 to the 23, right? Well, we only have 2 sig figs, so I'm getting 9.0 times 10 to the 23 gold atoms, right? Now, hopefully it's not completely foreign. We did that before we left. We also talked about molar mass, right? Molar mass is the mass of 1 mole, 6.022 times 10 to the 23 things, in grams. Now this is pretty straightforward actually, because remember, we can look at the periodic table to determine the molar mass. So for example, for carbon, right, if I want to know what's the molar mass of carbon, all I do is get the periodic table, which is over there if you remember. Well, you're not here, but anyway, and look at the bottom, the number at the bottom of the box, right? Which was also the mass in AMU of 1 atom, but it's the same thing as the molar mass in grams. So the molar mass of carbon is 12.01 grams of carbon per 1 mole of carbon, right? Again, remember this is a ratio, so I can flip it upside down if I wanted, but let's look at some other ones first real quick. What about the molar mass of oxygen? Again, I look at the periodic table. Grams of oxygen per 1 mole of oxygen. Usually I don't always write that 1 there, but it was assumed to be there, right? Remember, we had also extended this to molecules, right? If you have molecules, like let's say we had bromine, Br2 gas, okay, it comes diatomic molecule. So you have two bromines, right? So you have to look at the bromine on the periodic table. And bromine, sorry, I'm trying to look at it, 79.9. There's two of them. And I'm getting for bromine 159.8 grams of Br2 for every 1 mole of Br2, right? We do that with any molecule we want. So what about CO2, right? 1 carbon plus 2 oxygens. So 32 plus 12.01 is going to give us 34.01 grams of CO2 per 1 mole of CO2. Okay? So we had covered that, right? But now let's use this as a ratio. Again, we can use this as a ratio, similar to a unit conversion. We can flip it upside down if we need to, or do whatever we need to do. But let's take a look at an example. Yes, I'm going to end up doing a lot of erasing. Obviously, there's not a lot of room on the board, so let's take a look at an example. How many moles of sodium are in 3.8 grams of sodium, right? So I guess I should have pointed out again, molar mass is used to go between grams and moles, or moles and grams. So here, that's exactly what we're doing. We want to know the moles of sodium. We're given 3.8 grams of sodium, so what am I going to do? Or what are we going to do? Going to go from grams of sodium to moles of sodium like that. That's it. So again, starting off over here, moles of sodium. So again, I'm going to look up the molar mass for this, right? For sodium is 22.99 grams per mole. But what do I want? I want grams to cancel, okay? So I put the grams into the denominator. And I put moles here. That's what I want. Right? So basically I flipped it upside down, the molar mass. Grams cancels. Do your math. 3.8 times 1 divided by 22.99, enter. And I am getting 0.165. I only have 2 sig figs. So I'm getting 0.17 moles of sodium. Okay, hopefully this is semi-familiar, again, because we did this before we left. But let's take a look at another problem, another example. How many grams of NO3 are in, I don't know, 8.44 moles of NO3? Okay? So here, what do you want to know? We want to know grams of NO3. What's it giving us? 8.44, moles of NO3. So what am I going to do? Again, going to use the definition molar mass to go between grams and moles. So I'm going to go from moles of NO3 to grams of NO3. Again, where the arrows are ratio, and it's going to be the molar mass. all right? So we're gonna have to calculate the grams of NO3, but where are moles gonna go? Well, I want moles to cancel. I wanna end up with grams. So 1 mole of NO3 is gonna go down there. And then we're gonna calculate the molar mass in grams. So there's 3 oxygens. That's 3 times 16, that's 48, plus 1 nitrogen. And I'm getting 62.01 grams of NO3 for every 1 mole. Okay? Now do our math, that's all we needed. Moles cancels, and we're going to have 8.44 times 62.01 divided by 1. And I'm getting 523.3644 grams, but we only have 3 sig figs here, right? This does not count for sig figs. This does. We only have 3, so I have 523 grams of NO3. Okay? Again, hopefully that's making sense. If not, take a look in your book or email me, okay? Or email me. I don't know what else to tell you. All right? I guess we will continue on. Now we're going to combine our concepts. We can combine the concept of a mole with molar mass and do problems such as this, which I'll write out in a moment. Let's see here. How many atoms of helium are in, I don't know, 10.2 grams of helium? Okay? So we want to know number of He atoms. Question mark, right? We start off, we're given 10.2 grams of He helium. So what are we going to do? We're going to go from grams of He to moles of He. And then for moles of He, we'll use the definition of the molar mass, and we'll go to number of He atoms. So again, we're going to have 1, 2 conversion factors, okay? One's the molar mass, one's the definition of a mole. So let's start off here. Number of He atoms, I'm starting off, I have my 10.2, whoops, sorry, 10, not 6, 0.2 grams of He. Again, I'm going from grams of He to moles of He, I want grams to cancel. So I look at the periodic table, and I have 4.002 grams of He for every 1 mole of He, right? I just did the periodic table, right? Now, I want to go from moles to number of He atoms. So again, I'm using the definition of Avogadro's number. I want mole to cancel. So that goes into the denominator. 6.022 times 10 to the 23 He atoms goes up here. Sorry, ready to lift myself enough room. Let's check our units. Grams of He cancels, moles of He cancels, leaving us with number of He atoms, exactly what we want. Do your math. 10.2 times 1 times 6.022 times 10 raised to the 23rd and divided by 4.002. Provided I entered everything in correctly, we have 3 sig figs. I'm getting 1.53 times 10 to the 24 HE atoms, okay? Again, hopefully that makes sense. We did this before we left. We might have ended somewhere around here. But I'm pretty sure we did a couple of problems like this. But I'm gonna do one more. I'll do another one like this. Again, if you have questions, email me. We'll go the other way this time. Let's see here. Yeah, we'll go the other way. How many grams of, I don't know, we'll say methane are in 7.57 times 10 to the 24 CH4 molecules, okay? So how many grams of methane are in 7.57 times 10 to the 24 CH4 molecules? So again, I want to know grams of methane. What am I going to do? I'm starting off over there. I'm going to go from number of methane molecules. I'm going to use Avogadro's number, right, definition of a mole, to go from number of molecules to moles of CH4. Once I have moles of CH4, then I can calculate the molar mass, and we can go from moles to grams of CH4, just like that, right? Starting off, 7.57 times 10 to the 24 CH4 molecules. I'm not going to write that, so I'm going to run out of room. Okay, so I want number of molecules to go away, so I'm going to put Avogadro's number in the